Mercury is the closest planet to the Sun. On its surface, daytime temperatures can rise above 800 degrees Fahrenheit, hot enough to melt lead. But when night falls, that same surface can plunge below, minus 290 degrees Fahrenheit. That's a temperature swing of more than 1,000 degrees. No other planet in the solar system experiences anything like it. How can one world be both scorching hot and deeply frozen? How can the same ground that bakes under relentless sunlight turn into one of the coldest places in the inner solar system just months later? At first glance, the answer seems obvious. Mercury is close to the Sun, so it gets extremely hot. But distance alone doesn't explain the freezing nights. Venus is also close to the Sun, yet it doesn't experience anything close to this kind of temperature swing. The real reason Mercury is so extreme has less to do with how much sunlight it receives, and more to do with how it handles heat once it gets it. And that's where Mercury becomes one of the strangest planets in the solar system. Mercury orbits the Sun at an average distance of about 36 million miles, less than half the distance between Earth and the Sun. At that range, sunlight is far more intense. In fact, Mercury receives roughly 7 times more solar energy than Earth does. With no thick atmosphere to reflect or scatter that sunlight, the surface absorbs it directly. Rocky plains and cratered terrain bake under constant exposure, and because Mercury rotates slowly, that exposure lasts a long time. One full rotation on Mercury takes about 59 Earth days, but because of the way Mercury moves around the Sun, one full solar day, from sunrise to sunrise, lasts about 176 Earth days. That means once the Sun rises over a region on Mercury, it can hang in the sky for months. For weeks at a time, the same landscape is exposed to relentless solar radiation, allowing heat to build up to extreme levels. Temperatures climb past 800 degrees Fahrenheit, turning the surface into one of the hottest places in the solar system outside of Venus. But heat alone doesn't make Mercury extreme, because once the Sun finally sets, everything changes. When the Sun finally dips below the horizon on Mercury, the heat disappears almost instantly. Unlike Earth, Mercury has almost no atmosphere. There is no thick layer of air to trap warmth, no clouds to hold in heat, no weather system to redistribute energy from one side of the planet to the other. What little gas surrounds Mercury is so thin that it's closer to a vacuum than an atmosphere. On Earth, our atmosphere acts like insulation. Even after sunset, the ground slowly releases stored heat, and the air helps keep temperatures relatively stable. Mercury has no such protection. The heat absorbed during its long day radiates straight back into space. And because space is essentially empty and near absolute zero, the surface cools rapidly. Over the course of the long Mercurian night, which lasts months, temperatures can drop below minus 290 degrees Fahrenheit. The result is a world where the difference between day and night is more extreme than anywhere else in the solar system. But temperature swings are only part of Mercury's story. Its strange rotation and unusual orbit make its days and nights unlike anything we experience on Earth, and they play a crucial role in shaping this planet of extremes. Mercury doesn't just rotate slowly, it rotates in a way no other planet does. For every 2 orbits around the Sun, Mercury completes exactly 3 rotations on its axis. This 3-to-2 spin-orbit resonance creates one of the strangest day-night cycles in the solar system. Because of this precise rhythm, certain regions on Mercury experience long, lingering sunrises, where the Sun appears to rise, pause, move backward in the sky, and then resume its path again. This unusual motion changes how heat builds up across the surface. Some areas receive prolonged, intense sunlight, while others endure extended periods of darkness. The planet's already extreme temperature swings are amplified by this cosmic timing. But Mercury's orbit isn't the only unusual thing about it. Beneath its rocky surface lies an enormous iron core, making up roughly 85% of the planet's radius. That's proportionally far larger than Earth's core. Mercury is, in many ways, a massive ball of metal wrapped in a thin shell of rock. Despite being one of the smallest planets, Mercury even has a global magnetic field, something scientists didn't expect from such a small world. That magnetic field hints at a partially molten core still active deep inside. Yet even with that molten interior, Mercury cannot hold on to heat at the surface. Its thin outer layer and lack of atmosphere allow temperatures to swing wildly between burning and frozen. And as if that weren't extreme enough, Mercury is also slowly shrinking. As Mercury's massive iron core cools over time, it contracts. And when a planet contracts, its surface has to adjust. Evidence from NASA's Messenger spacecraft revealed enormous cliff-like features stretching for hundreds of miles across the surface. These scarps were formed as the planet's interior cooled and shrank, causing the crust to crumple and buckle. Scientists estimate that Mercury has shrunk by several miles in diameter over billions of years. That might not sound dramatic on a human scale, but on a planetary level, it's enormous. Entire regions of crust have been pushed upward, creating long ridges and steep cliffs that cut across ancient cratered terrain. Mercury isn't just extreme in temperature, it's structurally active, slowly changing as its interior cools and contracts. But perhaps the most surprising discovery about Mercury doesn't involve heat at all. Because in the darkest places on this scorching world, something unexpected has survived. Despite being the closest planet to the Sun, Mercury contains water ice. At first, that seems impossible. With daytime temperatures exceeding 800 degrees Fahrenheit, any exposed ice would vaporize almost instantly. But Mercury's axis is tilted by less than 1 degree, meaning some craters near its poles never receive direct sunlight. Inside these permanently shadowed craters, sunlight has not reached the surface for billions of years. Without solar heating, temperatures in these regions can remain hundreds of degrees below zero, cold enough to trap and preserve water ice. Radar observations from Earth first hinted at bright deposits inside these polar craters, and later, NASA's Messenger mission confirmed it. Beneath layers of dark material, there are substantial reserves of frozen water. On a planet defined by blazing heat, pockets of eternal darkness hold ice. It's a striking contrast, a world where one region can melt metal while another preserves frozen water just a few hundred miles away. Mercury isn't simply hot, it isn't simply frozen, it's both, at the same time. Mercury is easy to overlook. It's small, airless, and often lost in the sun's glare from our point of view on Earth. But up close, it reveals itself as one of the most extreme worlds in the solar system. A planet where temperatures swing by more than 1,000 degrees, where sunlight bakes the surface for months at a time, only for it to plunge into deep freeze during a night that lasts just as long. A world with a massive metal core, a shrinking crust, and ice hidden in craters that sunlight has never touched. Mercury isn't just close to the Sun, it's a planet of violent contrasts, burning and frozen, exposed and shadowed, ancient and still changing. And even now, after multiple missions, it continues to challenge our understanding of how planets form, evolve, and survive in the harshest conditions imaginable. Join us next time as we explore more mysteries of the universe.